Hello, this is Elizabeth Lesfrance, and this is for Dr. Sally Summersmith. So, I did my presentation on the reproductive system, specifically the male reproductive system, and sperm maturation in the germinal epithelium. So, it is important to note that there are two distinct organs. There's the female and the male reproductive system, where we're going to be focusing on the male. So some anatomy. So the testes, or the testicles, the gonads, make gametes or sperm. And the androgen hormone testosterone hangs and makes the androgen hormone testosterone. So the testes hang outside of the body in the scrotum, because they're extremely sensitive to temperature, and they prefer a cooler temperature so they can perform spermatogenesis for sperm production. The scrotum has the dartus and the cremaster muscle, which help with testicular temperature regulation. It relaxes to move the testes away from the body if it's too warm, or contracts and shrinks to pull them closer to the body if it's too cool. The sperm, it's very sensitive to temperature. It's surrounded by the tunica vaginalis and the inner tunica albuginea, which is a fibrous, and divided into lobules filled with semiferious tubules, which are tight coils and start the production of sperm. Semiferious tubules are made of stratified epithelium, which surround the central fluid-filled lumen. All right. So, Sertoli cells. Sertoli cells nourish developing sperm located inside the semiferious tubules, and they provide nutrients, protection for phagocytic activity, fluid, a hormone support for androgen binding protein, inhibin for negative feedback to regulate follicle stimulating hormone, Müllerian inhibiting factor during fetal development, and also the blood-testis barrier, which prevents pathogen entry into the testes. There's also Leydig cells outside, which excrete testosterone. Sperm will begin to grow outside the edge of the semiferious tubules and move towards the inside of the lumen. So what causes this? Well, it is a hormonal cascade. It's also important to note that there's not much investment in sperm, biologically speaking. It's pretty easy compared to the female process of making an egg. There's really just a tail and a nucleus, and it's the the amount of sperm that help to penetrate to reach the egg. So during puberty, which for males starts around at the age of 12, but it can start earlier, around age 9, Kisspeptin will stimulate gonadotropin-releasing hormone in the hypothalamus, which will then signal the anterior pituitary to release follicle-stimulating hormone and luteinizing hormone into the blood, as hormones do. This process will also happen in females, but the luteinizing hormone releases estrogen. So in males, the hormone causes the Leydig cells to release testosterone. The follicle-stimulating hormone will tell the Sertoli cells to release androgen-binding protein, and this will bind to testosterone, creating a concentration, which in turn triggers sperm production. Testosterone's main goal is to reach spermatogonia, and spermatogonia are the stem cells which allow sperm to begin, which is located at the outer layer of the semiferious tubule, and they start to divide. It is important to note, however, that even before puberty, spermatogonia cells are dividing via mitosis into two identical daughter cells. However, puberty with testosterone will make spermatogonia divide differently, and they divide into two distinct spermatogonia. So a daughter cell, or type A cell, will stay near the basal lamina and continue to divide. It will stay there, so it can keep going. The type B cell, however, right here, will go toward the lumen of the semiferious tubule and become a primary spermatocyte. It will then undergo meiosis 1 to form 2 haploid cells, which are then termed secondary spermatocytes. The next step is meiosis 2, and then it will become 4 spermatids, and they will then have 23 chromosomes at this point. This spermatogenesis is when the spermatid will grow a flagellum full of microtubules for movement and become have the ability to move, but it still can't move, if that makes any sense. For every spermatocyte, 4 sperm are born. Males can contribute X and Y chromosomes, and genetic sex determination is done with males since they have the Y. There's also the SRY gene, which produces testis determinating factor, which binds to DNA, activating additional genes such as SOX9, WT1, and SF1. And here's just a little picture of a sperm with a head, where the mitochondria are, and the microtubules would be in here. So the semiferious tubules contain myoid cells, which contact to push sperm and fluid from Sertoli cells out of tubules. They're then transported to the rudi testis. They leave this area through the epididymis, which is a tangled long tube. And there, this is what I meant by it's kind of confusing. They there gain the means of movement, even though they have tails. The epididymis contains a duct which contains microvilli known as stereocilia, and this allows for larger surface area and gives sperm nutrients and allows for fluid absorption. They then enter the inferior epididymis and now have their own mitochondria as an energy source. During ejaculation, sperm go through the vas deferens, which is part of the spermatic cord, and joins the duct of the seminal gland to create the ejaculatory duct. The ejaculatory duct goes through the prostate gland and empties into the urethra through the penis and into the external environment for fertilization. So, semen is the sperm, testicular fluid, and the gland secretions. It provides a means of transportation for the sperm, energy because it needs something to feed them, protection, and allows them to move. It helps with their motility. The seminal vesicles are hollow and behind the bladder, and they secrete a yellow, higher pH and alkaline fluid, which helps coagulate enzymes, has fructose in it, again, for nourishing and transporting sperm. It has, again, that higher pH to counteract the lower pH of urine, which is about 6, and the female vagina, which is a pretty acidic location. It secretes prostaglandins, which increase sperm success by decreasing viscosity of the female cervical mucus. There's also the prostate gland. During ejaculation, the prostate contracts to squeeze citric acid and enzymes into the urethra, which keeps semen in a liquid form. There's the bulbourethral glands below the prostate, which secrete clear mucus that drains into the urethra to remove the acidic urine, again, that pH of around 6, before ejaculation. So then there's the penis. The penis contains the glans penis, which is the tip. Some will have foreskin. It depends due to religion, and some people have concerns about hygiene. Again, some will have foreskin. Inside, there's erectile tissue, which is a dense connective tissue, and there's some smooth muscle. There's the corpus cavernosum and the corpus spongiosum. And it has vascular spaces that fill with blood during sexual arousal and vasodilate in the arteries to penetrate the vagina to fertilize. So outside of the body, it is semen, and then fertilization can happen. If the sperm is not ejaculated, if for whatever reason there's no sexual activity, it will be phagocytized and reabsorbed by the body. And that is that.